Hello, night travelers, those quiet souls who wander beneath the stars, seeking calm within the gentle symphony of the night. Welcome back to the Night Observer, a place where minds slow down, hearts grow lighter, and sleep arrives softly, carried by thoughts of the vast and mysterious universe. Tonight, I have lit a small bonfire. Once again, we gather around its steady warmth, listening as the flames whisper stories written across the cosmos. Together, we will lift our eyes to the sky, drift into the immensity above, and explore one of the universe's most enigmatic wonders, quasars. You will hear of chance encounters between scientists and these strange beacons of light, of discoveries that reshaped our understanding of the cosmos, and of why quasars remain among the most fascinating objects ever found. We will also touch upon the contrast between quasars and neutron stars, two seemingly opposite creations, yet equally essential in the grand narrative of the universe. Night travelers, allow your thoughts to rest. Gaze into the fire before you and let your mind wander freely. Imagine yourself seated in a comfortable armchair beside a wide window, looking out into a deep, velvety sky. No city lights, no noise, only silence and distance. In this quiet moment, I invite you to listen to a story of sounds no ear can hear and lights no eye can see. A story of strange specks of light hidden within cosmic radio music. The universe, it turns out, is not silent. It hums a wordless song through radio waves, a quiet melody humanity only began to hear in the middle of the 20th century. And it is here that our journey truly begins, when the universe's oldest lighthouses first called out to us from the depths of darkness. When the universe began to speak. The story opens in the 1950s, a time when traditional astronomy, dependent on glass lenses and visible light, stood at a crossroads. Scientists began constructing enormous new instruments, not to see the sky, but to listen to it. These were radio telescopes, vast metal ears turned toward the heavens. What they found was unexpected. Instead of silence, space was filled with mysterious radio noise. Most of these signals could be traced back to familiar galaxies, yet a handful of bright sources stood apart. They emitted radio waves of astonishing strength, but when astronomers aimed optical telescopes at their locations, they saw almost nothing, just a faint, solitary blue point of light. It looked like an ordinary star within our own Milky Way, but its radio song carried an energy far beyond anything a star could produce. Confounded, scientists gave these objects a tentative name, quasi-stellar radio sources. In time, the phrase was shortened, and the word quasar quietly entered the language of science. The mystery of 3C48 and 3C273. In the late 1950s, two such objects drew particular attention, 3C48 and 3C273. They were like ghosts in the radio sky. Astronomers Alan Sandage and Thomas Matthews managed to photograph 3C48, revealing its strange blue glow. But when they examined its spectrum, the chemical fingerprint of light, they met a wall of confusion. The emission lines were broad, distorted, and unlike those of hydrogen, helium, or any known element in a familiar state. The laws of physics, as they were understood at the time, offered no explanation. Scientists found themselves staring at something real, yet utterly incomprehensible. They did not know what it was made of, how far away it lay, or why it existed at all. Adding to the mystery was its size. These quasars showed none of the graceful spirals or massive shapes of galaxies. They were compact, mere pinpoints of light, so small they could vanish behind a speck of dust, yet powerful enough to flood vast regions of the sky with energy. A turning point, when the moon lended a hand. Clarity began to emerge in 1962 thanks to a rare alignment of chance and patience. astronomers John Bolton and Cyril Hazard realized that the moon would pass in front of quasar 3C273 several times. The moon became a moving screen, briefly blocking the radio signal before allowing it to return. These moments of disappearance and reappearance allowed scientists to pinpoint the quasar's position with extraordinary precision. The data was sent to Martin Schmidt at the Palomar Observatory. Using the great 200-inch Hale telescope, Schmidt finally obtained a clear spectrum of 3C273, and with it, the first real key to understanding what quasars truly are. And then, on a quiet evening in 1963, as Martin Schmidt studied the strange black and white lines etched onto the photographic film, a moment of clarity arrived, softly, almost without warning. He realized that those unfamiliar markings were not strange at all. They were the spectral lines of hydrogen, the most common element in the universe. Yet something was deeply wrong. These lines were no longer where they belonged. They had been stretched, displaced far toward the red end of the spectrum. This effect is known as redshift, and in the case of 3C273, the redshift measured an astonishing 15.8%. An almost unthinkable value at the time. The implication was unavoidable. 3C273 was not a nearby star. It was unimaginably distant, more than 2 billion light-years away. A light in the void. Once that distance was understood, a more unsettling truth revealed itself. For an object so far away to shine in our telescopes like an ordinary star, its intrinsic brightness had to be extraordinary. Calculations soon showed that 3C273 radiates roughly 100 times more light than the entire Milky Way galaxy, a galaxy that contains hundreds of billions of stars. Pause for a moment and let that settle in your thoughts. An object no larger than our solar system releasing as much energy as 1 trillion suns. This is the nature of a quasar, a luminous force that seems to defy the boundaries of reason. Then came another mystery, its flickering. Astronomers observed that a quasar's brightness could change within years, months, weeks, sometimes even days. In the universe, such rapid variation carries a clear message. Because light has a finite speed, an object cannot brighten or dim all at once unless it is physically small. This confirmed that quasars are astonishingly compact, often no larger than the solar system, yet powered by the most intense energy source ever known. The pairing of extreme smallness with extreme brilliance ignited decades of debate, challenging everything scientists believed about how nature could generate energy. Doubt, resistance, and human hesitation. It is human nature to resist what cannot yet be explained. In the 1960s, the idea of quasars existing at such immense distances was deeply unsettling. Some scientists rejected it outright. Alternative explanations were proposed. Perhaps quasars were nearby stars whose light was distorted by powerful gravitational fields. Others argued that no known process, certainly not nuclear fusion, could produce such overwhelming energy. Some even imagined quasars as chains of supernova explosions, erupting one after another like an endless display of fireworks. When the idea of supermassive black holes was introduced in 1964 by Edwin Salpeter and Yakov Zeldovich, it was met with skepticism bordering on disbelief. At that time, black holes were still theoretical constructs, mathematical shadows on Einstein's equations. Few believed they could exist in the real universe. Researchers found themselves struggling not only with incomplete data, but with their own doubt. Studying quasars, then, was like trying to see the center of a storm while standing inside its blinding light. Their brilliance drowned out everything around them. They appeared isolated, star-like, concealing the galaxies that hosted them. Only in 1973, with the arrival of more advanced instruments, did astronomers begin to notice faint, hazy glows surrounding these points of light. The subtle presence of entire galaxies wrapped around a powerful central engine. The night grows deeper now. and those distant points of light slowly fade in your imagination. You have followed their story, from the chaos of radio noise to Schmidt's quiet realization, to the long struggle of human understanding across decades. Quasars are not merely distant lights scattered across the sky. They are witnesses to a time when the universe was young, violent, and unfinished. They remind us that beneath the smallest appearances can reside unimaginable power. Now, allow this story to drift gently into your dreams. Out there, the universe continues its silent motion, and the great quasar lighthouses still shine, steadfast, ancient, carrying messages from the dawn of all things across the endless dark. Let the night gently settle around you, and allow your breathing to fall into rhythm with the deep stillness of the dark. We have already journeyed through those early, bewildering years when humanity first learned to hear the universe's faint radio music. Now, let your thoughts drift even farther, across billions of light years, toward what can only be called the heart of the ancient monsters. At the centers of the most distant galaxies dwell entities of ultimate power, places where the brightest light in the cosmos is born from the deepest darkness imaginable. The connection between quasar light and black hole darkness. To understand a quasar, picture a colossal lighthouse turning slowly in the vast ocean of space. Yet the source of that piercing beam is not a star. It is a supermassive black hole, hidden within darkness. We often imagine black holes as bottomless voids that swallow everything and leave only emptiness behind. In truth, when a black hole awakens, it becomes the most powerful engine the universe has ever known. Decades of observation have led scientists to a clear conclusion. Quasars are the visible manifestations of these cosmic giants. A quasar cannot exist without a black hole at its core, though a black hole may remain silent and unseen for eternity. Think of it as electricity and light. The black hole is the power source, while the quasar is the brilliant glow released when that energy finally flows. These are not ordinary black holes formed from the death of a single star. They are titans, weighing millions or even billions of times more than our sun. They reside at the centers of galaxies, acting as gravitational anchors, guiding billions of stars in an endless, slow dance. When such a black hole begins to feed, it reshapes the entire galaxy, turning what was once a dark, quiet core into a blazing furnace, so bright it can outshine hundreds of billions of stars combined. The birth of a quasar, when the monster awakens. A quasar is never born in calm or silence. It emerges from one of the most violent chapters in cosmic history. Most of the quasars we observe belong to a distant era, nearly 10 billion years ago, when the universe was young, crowded, and rich with primordial gas. This was the golden age of quasars, a time when galaxies frequently collided and merged. The birth of a quasar begins when vast reservoirs of gas and dust are driven toward a galaxy's center, where the supermassive black hole lies in wait. The collision of two galaxies is the perfect trigger. Gravitational order collapses, and matter that once moved in stable orbits suddenly loses balance, rushing inward toward the black hole's immense pull. As this matter approaches, it does not plunge straight in like a stone dropped into a well. Bound by the laws of angular momentum, it begins to spiral, forming what astronomers call an accretion disk. Imagine a vast cosmic whirlpool, not of water, but of superheated plasma, dust, and shattered stars. Within this swirling disk, particles collide at velocities approaching the speed of light, generating tremendous friction. That friction, combined with overwhelming gravitational pressure, heats the disk to millions of degrees. Gravitational energy is transformed into heat and radiation, and the disk ignites with an intensity visible across billions of light years. In that moment, a quasar is born, the quiet black hole transformed into a blazing, luminous monster, announcing its presence across the universe. Now, Let that image soften and fade as the night deepens. The ancient engines continue their work far beyond our sight, while here, beneath the calm sky, you are free to rest, listening, breathing, and drifting gently toward relax. The terrifying power of the cosmic engine. If it were possible to truly feel the power of a quasar, every supernova explosion and every burst of solar energy would seem no more than a fleeting spark within a vast cosmic storm. The strength of a quasar lies in its extraordinary efficiency at converting matter into energy, far surpassing any physical process known to humanity. Nuclear fusion in the cores of stars transforms only about 0.7% of mass into energy. A quasar, by contrast, can convert between 6 and 32% of matter directly into light and radiation. To sustain such overwhelming brilliance, these cosmic engines must feed at an astonishing rate. A typical quasar consumes the equivalent of 2 Earths every second. The brightest among them devour nearly 1,000 solar masses each year, merely to maintain their luminous halos. The energy released can exceed the combined output of the entire Milky Way by thousands of times. Were a quasar located just 33 light-years from Earth, it would shine in our daytime sky with the intensity of our own sun. Yet light alone does not define their power. Quasars also generate jets of unimaginable force. As the black hole spins, it drags the very fabric of space-time with it, a phenomenon known as frame dragging. Enormous magnetic fields capture some of the infalling matter before it crosses the event horizon, hurling it outward from the black hole's poles. These jets, composed of high-energy particles traveling at nearly the speed of light, can stretch across millions of light-years, slicing through entire galaxies and reaching deep into intergalactic space. Such power allows a quasar to reshape its host galaxy through a process astronomers call feedback. The intense radiation and powerful winds can drive away cold gas clouds, quietly halting the birth of new stars. Vast shockwaves, cosmic tsunamis, can surge through space at tens of millions of kilometers per hour, stripping planets of their atmospheres and permanently altering a galaxy's structure. Monsters in silence. After millions of years of blinding activity, every quasar eventually grows quiet. When the surrounding gas and dust are exhausted, the accretion disk fades, the jets subside, and the once brilliant beacon returns to silence. What remains is a supermassive black hole, resting at the center of its galaxy, like a distant echo of an ancient fire. Our own Milky Way harbors such a heart. Sagittarius, a star. Today, it lies dormant, gently nibbling at small amounts of matter. Yet enormous structures such as the Fermi bubbles, towering regions of energetic gas rising above and below the galactic core, stand as silent testimony that our galaxy once shone with quasar-like intensity. As you gaze into the night sky, remember that the calm we experience is a gift of time. Those ancient monsters still exist, hidden in shadow, waiting patiently for future galactic encounters that may awaken them once more. Now, as the immense power of quasars fades into the distance, allow a sense of peace to take its place. These titans are so far away that their light has traveled billions of years to reach us. Here, within the gentle protection of a quiet solar system, our central black hole remains in deep and peaceful slumber. Let your breathing soften. Feel the vastness of the universe, not as something threatening, but as a wide and steady cradle, guiding you toward rest. The cosmos continues its work with patience and grace. The distant stars seem to watch quietly, guarding your dreams. Night travelers, close your eyes now. Let your body sink into the stillness of the night and allow your thoughts to drift once more. We have witnessed the chaos unleashed when black hole giants awaken. But now, as their ancient light finally reaches us, the story grows gentle again. Welcome to the sculptors of the universe and the peaceful silence. In this chapter, we no longer see quasars as destroyers. but as careful artisans, forces that shaped the structure of the universe in which we live, and then stepped back into silence, leaving behind a cosmos ready for life, reflection, and rest. The unique features of an eternal lighthouse. To understand why quasars hold such a central place in modern astronomy, we must return to the qualities that make them the most powerful objects ever observed. A quasar is not merely a distant point of light. It is a cosmic thermal engine of extraordinary efficiency. While stars like our Sun convert only about 0.7% of their mass into energy through nuclear fusion, a quasar can transform between 6 and 32% of matter directly into light and radiation. By any natural standard, this efficiency is astonishing, dozens of times greater than that of any stellar process. Perhaps the most remarkable feature of a quasar is the union of extreme brightness with extreme compactness. Picture an object no larger than our solar system, yet shining thousands of times more brightly than the entire Milky Way, a galaxy that contains hundreds of billions of stars. Because quasars are so compact, their brightness can change rapidly, sometimes over the course of days or weeks. In the language of physics, this tells us something profound. The region producing that immense energy must be tightly concentrated, since no signal can travel faster than light to coordinate changes across a larger structure. Quasars also speak to the universe in many voices. They emit not only visible light, but powerful streams of X-rays, ultraviolet radiation, and radio waves that pierce the depths of space. Around 10% of them launch colossal jets, narrow beams of charged particles traveling at nearly the speed of light, stretching millions of light years into intergalactic darkness. These jets act like the first chisels, carving structure into the vast emptiness between galaxies. Quasars, sculptors in the formation of galaxies. The universe we see today appears calm and organized, with well-defined galaxies drifting gracefully through space. But billions of years ago, it was anything but peaceful, a turbulent sea of gas and dust. In this early chaos, quasars played the role of regulators through a process astronomers call feedback. Young galaxies tend to form stars at a furious pace, rapidly consuming their reserves of cold gas. When the central black hole feeds too aggressively and ignites as a quasar, the resulting radiation and powerful winds drive much of that gas outward, away from the galaxy itself. At first glance, this may seem destructive, yet it is more like a careful pruning. By slowing runaway star formation, quasars preserve a galaxy's material, allowing it to mature gradually over billions of years. The bond between a galaxy and its quasar is remarkably intimate. Observations show that the mass of a galaxy's central black hole is closely proportional to the mass of the galaxy surrounding it. This suggests that the two grew together, step by step, like partners in a slow cosmic dance governed by gravity and light. Without the regulating influence of quasar outbursts, our own Milky Way might have exhausted its gas long ago, aging into silence before life ever had the chance to emerge. Light through the Dark Ages, Rionization. Quasars also played a vital role as the universe's first great beacons. About 380,000 years after the Big Bang, the cosmos entered a long period known as the Dark Ages. Space was filled with neutral hydrogen gas, thick and opaque, preventing light from traveling freely. When the first quasars ignited, their intense ultraviolet radiation stripped electrons from these hydrogen atoms, turning the foggy universe transparent once more. This transformation, known as reionization, was a turning point in cosmic history. Alongside the earliest generation of stars, quasars helped clear the darkness, allowing light to journey across billions of light years and eventually reach our eyes. Even today, quasars continue to teach us about the early universe. As their light travels toward Earth, it passes through countless clouds of gas, each leaving its signature as a thin absorption line in the quasar's spectrum. These lines form what astronomers call the Lyman alpha forest, resembling the marks of an immense barcode. Each line records the presence of a distant cloud, enabling scientists to trace the vast invisible structure of the cosmos, the delicate filaments of the cosmic web that bind all matter together. In the quiet of the night, quasars remind us that even the brightest lights are not merely spectacles, but careful architects, shaping the universe slowly and patiently, long before we were here to listen. Questions and the expansion of the universe. The study of quasars does more than expand our knowledge of distant light. It gently leads us into some of the deepest unanswered questions of modern physics. Through quasars, we first learned that the universe itself is expanding. Because these objects lie at the very edge of visibility, their light is stretched more than any other, as space slowly unfolds between them and us. Yet when scientists attempted to measure the exact rate of this expansion, known as the Hubble constant, they encountered a quiet but profound contradiction, now called the Hubble tension. Measurements derived from the early universe, using the cosmic microwave background, point to one value. Direct measurements made much later in cosmic history, using quasars and supernovae, suggest a rate nearly 9% higher. The difference may sound small, but in cosmology, it is enough to shake the foundations of our understanding. Quasars have become especially valuable through the phenomenon of gravitational lensing. When a massive galaxy drifts between us and a distant quasar, its gravity bends the quasar's light, splitting it into multiple images. As the quasar subtly brightens and dims, these images change at slightly different times. By measuring these time delays, astronomers can calculate distances across the universe with remarkable precision. Again and again, these measurements tend to favor the higher expansion rate, quietly suggesting that something, perhaps dark energy, perhaps a deeper law of nature, remains beyond our grasp. Equally unsettling is the discovery of large quasar groups. Some of these immense structures stretch across billions of light years. One, known as the huge LQG, spans nearly 4 billion light years, far larger than what our models predict for a universe that is uniform on the largest scales. These discoveries invite a gentle but persistent question. Is the universe truly smooth and even in all directions? Or does it hide vast patterns we have not yet learned to read? The peaceful silence and our future. As your breathing slows, turn your thoughts closer to home, to the black hole at the center of our Milky Way. Sagittarius, a star. Today it rests in silence, a dormant quasar that consumes only a small amount of matter each year. Yet the enormous Fermi bubbles rising above and below our galaxy's core are lasting echoes of a time when it burned brightly, millions of years ago. We live within this calm interval, a rare and precious pause that allows life to grow, undisturbed by lethal waves of radiation. But silence, in the universe, is never permanent. In 4 to 5 billion years, the Milky Way will merge with its great neighbor, the Andromeda Galaxy. Their central black holes will spiral together, and the chaos of that encounter will drive vast rivers of gas into the core. A brilliant new quasar will ignite at the heart of our future galaxy, a violent yet magnificent rebirth written into cosmic time. And so the story of the great cosmic sculptors draws gently to a close. Quasars are not merely distant points of light. They are ancient ancestors, patient guardians, and the oldest witnesses of the universe's unfolding. They remind us that the brightest radiance often rises from the deepest darkness, and that the stillness we feel tonight is only a resting note within a much larger symphony. Let the image of those streaming lights fade softly from your thoughts. You are here, safe within the arms of the Milky Way, where the stars keep watch over your sleep. The universe continues its slow, steady expansion, breathing in silence, rocking you gently among the galaxies. Imagine the quasar as a great lighthouse on a dark, endless sea, not only guiding distant travelers, but clearing the fog itself, shaping quiet harbors where new stars may one day be born. The night grows deeper, and as the noise of the world slowly recedes, only the rhythm of your breathing remains, dissolving gently into the vast stillness of space. Imagine yourself drifting through a quiet ocean of stars, where time is no longer measured by hands on a clock, but by endless rivers of light. In this calm, I invite you to reflect with me on one of the universe's most magnificent, mysterious, and paradoxical creations, quasars, the so-called quasi-stars, the silent sculptors of space and time. To me, a quasar is far more than a technical term in astronomy. It is a hymn to beginnings, a living echo from an era when the universe was young, restless, and unfinished. When we gaze through a telescope at a tiny, dim point of light, few of us would imagine that we are confronting a monster whose power rivals that of thousands of galaxies combined. There is something quietly poetic and faintly unsettling in knowing that this fragile glimmer has traveled for billions of years through cold and empty darkness, simply to reach our eyes and tell its ancient story. That story begins as a soft but curious whisper in the universe's radio symphony. In the 1950s, when humanity first learned to listen to the sky with radio telescopes, astronomers encountered sources of radiation so intense they seemed almost impossible. These signals stood out like sharp, unexpected notes within the gentle harmony of ordinary galaxies. Scientists were puzzled. They observed faint blue points of light, small and compact, resembling stars, yet releasing energy that defied everything physics could explain at the time. The name quasi-stellar radio sources was born, a humble admission of how little we understood what we were seeing. I often find myself wondering what Martin Schmidt felt on that quiet night in 1963, seated beneath the great dome of the Palomar Observatory, patiently deciphering the message carried by Quasar 3C273. When he realized that its spectral lines were dramatically shifted toward the red, he was not merely identifying an object at an unprecedented distance. He was opening a window into the universe's own past. That red shift revealed a universe in motion, one that is expanding, with galaxies drifting apart upon the fabric of space-time itself. Quasars became markers of this expansion, cosmic beacons reminding us that space is not a fixed container, but a canvas that is constantly being stretched. The true uniqueness of quasars lies in the quiet paradox they embody. Consider this: the brightest, most radiant light in the universe is born from the deepest darkness, supermassive black holes. These invisible hearts, millions or even billions of times more massive than our sun, lie hidden within ancient galaxies. They are often imagined as voracious mouths consuming everything nearby. Yet in truth, it is precisely when a black hole begins to feed that it transforms into the most powerful engine nature has ever devised. The birth of a quasar is a dramatic union of fire and darkness. When galaxies collide and merge, a common event in the early universe, vast reservoirs of gas and dust are driven toward their shared center. Under immense gravitational force, this matter does not plunge straight into the black hole. Instead, it spirals inward, forming a brilliant accretion disk. Within this glowing whirlpool, friction and pressure convert matter into energy with astonishing efficiency, ranging from 6 to 32%, far surpassing the nuclear fusion that powers stars. Quasars do not shine through gentle burning, but through matter pushed relentlessly to the very edge of existence. From the glowing accretion disk, jets carrying immense and deadly energy are launched at nearly the speed of light, piercing through space for millions of light years. In quasars, I sense a force that is both destructive and creative at the same time. They can consume matter equivalent to 2 Earths every single second, yet it is precisely this overwhelming intensity that allows them to become the universe's great sculptors. Few people realize that without these so-called monsters, our Milky Way might never have known the calm stability it enjoys today. Quasars generate what astronomers call a feedback effect. When they erupt, Their radiation and winds sweep away vast clouds of cold gas from their host galaxies. It may seem harsh, but it is much like a careful gardener pruning excessive growth. By preventing runaway star formation, galaxies are spared from exhausting their fuel too quickly. They can mature slowly, gracefully, over billions of years, long enough for planets to settle and for life, eventually, to take root. In this sense, quasars traded their brief, blinding brilliance for the quiet endurance of future generations of stars. Across the long history of the cosmos, quasars also served as the first torchbearers, illuminating what we now call the Dark Ages. After the Big Bang, the universe was wrapped in a dense fog of neutral hydrogen, a time when light could travel only short distances. It was the fierce ultraviolet radiation from the earliest quasars that pierced this veil, ionizing the gas and making the universe transparent once more. They cleared the cosmic mist, allowing light to journey freely across space and time. Every star you see shimmering gently in the night sky owes its visibility, in part, to those ancient beacons that prepared the way. Yet quasars also remind us of impermanence and humility. Their light endures only as long as there is matter to feed them. When the surrounding gas is exhausted, the brilliance fades, leaving behind a silent, solitary black hole at the galaxy's core. Our own Milky Way harbors such a presence, the black hole Sagittarius, a star, now resting quietly at the center of our home. Vast structures like the Fermi bubbles stand as scars from an earlier age, when our galaxy, too, once flared with quasar-like intensity. We are living within a rare and peaceful pause in a far more turbulent cosmic story. That silence is a precious gift, but it is not eternal. In 4 to 5 billion years, when the Milky Way and the Andromeda Galaxy slowly merge, torrents of gas will once again flow toward the center. Our black hole will awaken, nourished by fresh matter, and a new quasar will ignite, brilliant and awe-inspiring, at the very heart of our galaxy. It will mark a new chapter of rebirth, a quiet reminder that in the universe, endings and beginnings are often inseparable. The study of quasars also draws humanity into profound questions about reality itself. We use them to measure the universe's expansion, only to uncover unsettling contradictions, such as the so-called Hubble tension. Perhaps quasars are gently telling us that our understanding remains incomplete, that the universe still holds truths beyond the reach of our current language and equations. Now, let your breathing soften, like stardust drifting unhurriedly through space. You have witnessed quasars born from cosmic storms, blazing with godlike intensity, shaping galaxies, and then dissolving into eternal stillness. You are part of that same grand flow. The atoms within your body were once forged in stellar hearts, perhaps even stirred within the furious whirl of an accretion disk billions of years ago. The vast universe continues its slow and patient expansion, carrying distant quasars ever closer to the edge of infinity. But here, in this quiet moment, they become gentle points of light, guiding your thoughts toward rest. Let their brilliance fade from your mind, giving way to deep peace. The stars stand watch over your sleep, and the universe holds you within its boundless embrace. Imagine the quasar as a single, towering candle burning in a pitch-dark room. Its flame reveals what was once hidden, and its warmth reshapes the wax into new forms, until at last, the light goes out, leaving behind a thoughtful and enduring silence. Are you still awake, night travelers? If you have already drifted into sleep, that is perfectly fine. And if you are still awake, take a slow, deep breath. Feel your chest gently rise, then fall again in a calm, unhurried rhythm. Let the warmth of this quiet moment carry your thoughts a little farther. You are lying beneath a deep and endless night sky, where the glow of city lights has long faded into memory. Around you is the silence of all things, broken only by the soft whisper of the wind and the steady sound of your own breathing. Tonight, we are not searching for nearby stars. Instead, we allow our minds to wander to the farthest reaches of space and time. Together, we will gaze upon quasars, magnificent lighthouses burning at the very edge of the visible universe. This is Lighthouses at the Edge of Time, a story of distances so vast they defy all familiar measures, and of beams of light so powerful they are able to lift the darkness of an entire era. Our story begins not with the eyes, but with the ears of science. In the 1950s, when humanity first built the great ears of radio telescopes to listen to the universe, astronomers detected a strange and restless melody in the sky. Among the gentle radio murmurs of distant galaxies were sharp, unexpected signals, out of place, unsettling. When optical telescopes were turned toward these sources, they revealed only faint, solitary blue points of light, no different in appearance from ordinary stars in our own Milky Way. Yet this was a profound deception. These so-called stars did not behave like their quiet neighbors. They released enormous amounts of energy across every wavelength, from radio waves to X-rays, while remaining astonishingly compact. Faced with this contradiction, scientists gave them a temporary name born of uncertainty: quasi-stellar radio sources. From that cautious description, the word quasar quietly entered our language. In 1963, a pivotal moment arrived. Astronomer Martin Schmidt, studying the quasar known as 3C273, noticed that the dark and bright lines in its spectrum were not strange at all. They were the familiar fingerprints of hydrogen, but stretched dramatically toward the red end of the spectrum. This redshift was more than a curiosity. It was a key. It revealed a distance so vast that it forever altered humanity's understanding of the universe. Distance dissolves all familiar boundaries. Let your thoughts relax as we speak of distance now. On Earth, we measure space in kilometers. A kilometer is a short walk. But in the universe, kilometers become fragile and meaningless. A single light year, the distance light travels in 1 year at 300,000 kilometers per second, is about 9.46 trillion kilometers. To count to 1 trillion at one number per second would take more than 31,000 years, longer than the entire span of recorded human history. And yet, the nearest quasar to us, Markarian 231, lies some 600 million light-years away. Its light began its journey when Earth was still home to the simplest forms of life, long before the first dinosaurs ever walked the land. That, however, is only the beginning. Quasar 3C273 resides more than 2 billion light-years from us, and the most distant quasars ever observed, such as UHZ1, possess redshifts as high as 10.1, corresponding to a comoving distance of roughly 31.6 billion light-years. Imagine the universe as a vast and silent ocean, and our solar system as a single grain of sand resting on its shore. Quasars stand like distant lighthouses along the far horizon, where space stretches thin and time begins to blur. Because light travels at a finite speed, to look at a quasar is not merely to look across space, it is to look back through time toward the universe's earliest chapters, when it was only a few 100 million years old. Quasars are relics of light, ancient messengers carrying stories from a brilliant and violent era that vanished billions of years ago. They remind us that even in the deepest darkness, the universe once burned with extraordinary intensity, leaving behind signals gentle enough to reach us tonight as we rest beneath the quiet sky. Close your eyes, allow your body to soften, and let your breath settle into its own quiet, natural rhythm. We have already passed the first moment of wonder, when humanity learned to hear the faint radio music of the cosmos. Now, let your thoughts drift farther still, across billions of light years, toward a place known only as the heart of the ancient monsters. At the cores of the most distant galaxies dwell entities of ultimate power, where the brightest light in the universe is born from the deepest darkness. The connection between quasar light and black hole darkness. To understand a quasar, Imagine a colossal lighthouse turning slowly in the endless ocean of space. Yet the source of its terrifying beam is not a star, but a supermassive black hole hidden in shadow. We often think of black holes as bottomless voids, silent wells that swallow everything and leave nothing behind. In truth, the universe tells a more subtle story. When a supermassive black hole awakens, it becomes the most powerful and efficient engine nature has ever created. Astronomers have shown that quasars are the visible, radiant faces of these dark giants. A quasar cannot exist without a black hole at its center, though a black hole may remain silent for eternity if it has nothing to feed upon. Think of electricity and a lamp. The black hole is the unseen power source, while the quasar is the brilliant glow released when that energy finally flows. These are not ordinary black holes formed from dying stars. They are titans, millions or even billions of times more massive than our sun. They rest at the hearts of galaxies, anchoring billions of stars in a slow gravitational dance. When such a black hole begins to feed, the galactic core is transformed from darkness into a blazing furnace that can outshine hundreds of billions of stars combined. The hunger of monsters, the accretion process. A quasar is born when vast reserves of gas, dust, and even wandering stars are driven toward a galaxy's center. The collision and merger of galaxies often serve as the spark, disturbing long-established orbits and sending matter spiraling inward, helplessly drawn toward the black hole's immense gravity. Yet this matter does not fall straight in, like a stone into a well. Bound by the laws of motion, it begins to whirl at extraordinary speeds, forming what is known as an accretion disk. Picture this disk as a cosmic maelstrom, a vast whirlpool not of water, but of searing plasma, dust, and shattered stellar remnants. Within it, particles collide at velocities approaching the speed of light. Friction and gravitational pressure rise to unimaginable levels, heating the disk to millions of degrees Kelvin. It is here that matter is transformed into pure energy. To sustain its radiant halo, a quasar may consume the equivalent of several Earths every second, or nearly 1,000 suns worth of material each year. This process surpasses all familiar forms of energy production. While nuclear fusion in stars converts only about 0.7% of mass into energy, a quasar can transform between 6 and 32%, and in some cases even more, of matter into light and radiation, depending on how fast the black hole spins. These ancient monsters are not merely voracious. They are cosmic power plants of unmatched efficiency, burning at the very limits of physical law. Let this image linger gently in your mind. The quiet breath, the turning lighthouse, the hidden darkness giving rise to impossible light. As the universe continues its patient work far beyond the reach of time. What quasars give back? Light, relativistic jets, and cosmic winds. Quasars do not merely consume. In their awakening, they also return to the universe torrents of energy and matter, terrifying in scale, yet strangely magnificent. The most immediate gift is light itself. Quasars release electromagnetic radiation across the entire spectrum, from gamma rays and powerful X-rays to visible light, ultraviolet, infrared, and radio waves. This outpouring is so intense and so steady that quasars become the brightest beacons in the observable universe, visible across distances of more than 13 billion light-years. Equally astonishing are their relativistic jets. As matter spirals toward the black hole, not all of it is lost. Caught in immensely strong magnetic fields, a fraction is redirected and expelled from the black hole's poles. These jets are streams of high-energy particles traveling at nearly the speed of light, stretching millions of light-years into space. They pierce through entire galaxies and reach far into the intergalactic void, carrying heat and energy that can shape vast regions of cosmic structure. In doing so, they prevent cold gas from collapsing too quickly, quietly regulating the birth of new stars. Quasars also generate what astronomers call feedback, sometimes described as a quasar wind or tsunami. The pressure from intense radiation drives enormous flows of gas and dust outward at tens of millions of kilometers per hour. These winds can strip planets of their atmospheres and suppress star formation across entire galaxies. Though this sounds destructive, it serves a deeper balance. By slowing the rate at which stars are born, quasars prevent galaxies from exhausting their fuel too early, allowing them to evolve steadily over billions of years. Quasars as the alchemists of the universe. Despite their fearsome reputation, quasars are essential architects of cosmic life. Their jets and winds do more than carry energy. They disperse heavy elements forged in the violent environment of the accretion disk. These elements drift into interstellar space, becoming the raw material for future stars, planets, and ultimately, worlds like our own. Long ago, the light of ancient quasars also transformed the universe itself. After the Big Bang, space was filled with a fog of neutral hydrogen that trapped light. The powerful ultraviolet radiation from quasars helped clear this haze, a process known as ionization. By doing so, they rendered the universe transparent, allowing light to travel freely across immense distances. In this way, quasars became master sculptors, shaping the rhythm and structure of galaxies over cosmic time. Now, as the memory of their brilliance softens in your thoughts, allow a sense of calm to settle in. These ancient monsters are unimaginably distant, their light taking billions of years to reach us. You are here, safe within the quiet shelter of a peaceful solar system, where our own central black hole, Sagittarius A star, rests in long slumber after its distant era of fire. Let your breathing grow lighter. Feel the vastness of the universe not as something threatening, but as a gentle cradle, vast and patient, carrying you toward rest. The cosmos continues its work silently and faithfully. Imagine the quasar as a powerful storm glowing on the far horizon. It sweeps away old clouds, clears the sky, and scatters the seeds from which new life will one day grow. In that balance, between destruction and creation, the universe finds its enduring harmony. Are you still awake, night travelers? Take a deep breath. Let your chest rise gently, then slowly fall, following the calmest rhythm you know. The night has grown late. As the sounds of the world recede, only your breathing remains, merging with the vast stillness of space. We have journeyed through the stormy chapters of creation, the birth of black hole giants, and the overwhelming power they unleash. Now it is time to return to calm. Welcome to peace in the embrace of distance. This is the story of why, in a universe filled with deadly lighthouses of light, we can still rest in safety, and how those very lights have helped humanity trace the unseen map of the cosmos. The Shield of Infinity. Distance between Earth and quasars. The universe is a boundless ocean, and our solar system is a small, quiet grain of sand on the far outskirts of the Milky Way. When we speak of quasars, beings capable of consuming the mass of 2 Earths each second and shining thousands of times brighter than our entire galaxy, it is natural to feel a quiet unease. But be at ease. We are protected by the strongest shield known to nature: distance. The nearest quasar, Markarian 231, lies about 600 million light-years from Earth. Its light began its journey when our planet was still ruled by simple single-celled life, long before dinosaurs ever walked the land. Others are farther still, 3C273 at more than 2 billion light-years, and the distant quasar UHZ1 at a staggering 31.6 billion light-years in co-moving distance. This immense separation is a gentle, protective embrace. By the time the fierce radiation of quasars reaches our solar system, it has faded into the faintest whisper, detectable only by the most sensitive instruments and harmless to life on Earth. We live in a fortunate era of quiet, where these cosmic beacons are merely pale points of light, carrying memories of a distant and violent past. If distance were gone, the quasar tsunami. Allow your mind to wander briefly, so you may better appreciate the peace of the present. Scientists have calculated that if a quasar like 3C273 were placed just 33 light-years from Earth, no farther than a few neighboring stars, it would blaze in our daytime sky with a brilliance rivaling the sun itself. Yet beauty, in this case, would carry devastation. Quasars unleash jets and powerful feedback capable of sweeping entire galaxies clear of cold gas. Astronomers call this a quasar tsunami. These winds race through space at tens of millions of kilometers per hour. If such a wave passed through our solar system, Earth would lose its atmosphere in moments. Our blue world would be stripped bare, life erased in an instant. Intense ultraviolet and X-ray radiation would tear apart the very molecules of biology. But take comfort. No such danger exists. The universe is expanding, and quasars are drifting ever farther away, carried into the deepening void. Sculptors of the Milky Way and our origins. Though fearsome in power, quasars have been master sculptors of our galaxy. The Milky Way has endured ancient collisions and mergers, and in those turbulent times, our central black hole, Sagittarius, a star, may have awakened, shining briefly as a quasar. These outbursts acted as a cosmic regulator. By heating and dispersing excess gas, they slowed star formation, preventing the galaxy from burning through its fuel too quickly. Without this balance, the Milky Way might have grown old and silent long before our sun was born. Quasars are also the universe's quiet alchemists. The elements that make life possible, iron in our blood, calcium in our bones, oxygen in our breath, were not only forged in stars, but spread across space by the immense winds and jets of quasars. In a profound sense, we are composed of ancient explosions and distant light, patiently gathered by gravity into conscious form. Now, night travelers, let that understanding settle gently within you. You are safe, wrapped in distance, time, and silence. The great lighthouses of the cosmos shine far away, and here, in this quiet corner of the universe, sleep comes easily. Quasars, the landmarks of cosmic measurement. In astronomy, quasars are more than distant objects to admire. They are our most reliable measuring tools, the quiet landmarks by which we chart the vastness of space-time. Because of their extraordinary brightness and immeasurable distance, quasars serve as steady lighthouses, marking the framework of the universe itself. The International Celestial Reference System, the backbone of modern astronomy, relies on hundreds of extragalactic radio sources, primarily quasars, scattered across the sky. So distant are they that, to our finest instruments, they appear perfectly motionless. Using very long baseline interferometry, scientists can locate these beacons with astonishing precision, down to 0.001 arcseconds. With this invisible grid in place, we can track the motion of stars and planets, and even measure the subtle rotation of the Earth beneath our feet. Quasars also help us read the story of the universe's expansion. By studying their redshift, Edwin Hubble and later Martin Schmidt revealed that space itself is stretching, quietly and relentlessly. Quasars become cosmic barcodes. As their ancient light travels toward us, it passes through clouds of gas, leaving delicate absorption signatures known as Lyman alpha forests. Each line in this forest records the density and position of matter long ago, allowing astronomers to trace the vast filaments of the cosmic web. Future puzzles and the expanding cosmos. As we continue to study quasars, we edge closer to one of modern physics' most intriguing puzzles, the Hubble tension. This is the disagreement between the universe's expansion rate measured from its earliest light, the cosmic microwave background, and the rate measured from later epochs using quasars and supernovae. Quasars offer an independent path to clarity through gravitational lensing. When a galaxy lies between us and a distant quasar, its gravity bends the quasar's light, creating multiple images, sometimes arranged like an elegant cross. As the quasar subtly varies in brightness, each image responds at a slightly different time. By measuring these delays, scientists can calculate the expansion rate of the universe with remarkable accuracy. The results challenge our understanding, urging us to rethink the fundamental laws of physics or the true nature of dark energy shaping the destiny of space itself, the gift of silence and the rest of time. Now, allow that knowledge to settle gently within you. Our Milky Way has entered a quiet phase, stable, unhurried, at rest. At its center, the black hole Sagittarius A star sleeps, consuming only a trace of matter each year, no longer the radiant quasar it once may have been. This calm is a priceless gift. It grants the solar system a steady home, where planets can circle the sun in near-perfect harmony for billions of years. We live in a kind of galactic Goldilocks zone, safely distant from the storms of radiation near the core and the crowded chaos of dense star regions. Yet the universe is patient, and its story is not finished. In 4 to 5 billion years, the Milky Way and the Andromeda Galaxy will begin their slow, majestic merger. As their central black holes draw together, torrents of gas will ignite a new quasar at the heart of our future galaxy, a brilliant renewal where destruction and creation meet once again. But this chapter lies so far ahead that it need not trouble your rest tonight. The tale of these lighthouses at the edge of time now comes to a close. Quasars are not merely distant points of light. They are our guides, our witnesses, and our teachers. They remind us that peace and violence coexist in the universe, and that distance itself is nature's way of protecting fragile life. Let the image of quasar light slowly fade from your thoughts. You are here, safe within the gentle arms of the Milky Way, while the stars stand watch over your quiet sleep. The universe continues to expand, slowly, patiently, rocking you into rest beneath its endless canopy. Imagine a quasar as a great lighthouse on a dark cosmic sea. Its powerful beam once cut through the fog, guiding travelers and shaping new beginnings. Then, in time, it dimmed, leaving behind clarity, balance, and a profound contemplative silence. Night travelers, if you are still awake, take a moment to look into the warm glow of the fire before you. Imagine yourself standing inside an ancient library, one where books are not written with ink and paper, but with beams of light that have traveled for billions of years through eternal darkness. Each page you turn is a fragment of cosmic memory, recording moments of violence and beauty, of birth and disappearance. We have listened to faint radio whispers from the depths of space. Tonight, let your breathing slow. Let your thoughts drift gently along the river of time, all the way to the farthest edge of remembrance. Welcome to the Children of Glorious Death, the story of two of the universe's most remarkable creations, born from the ashes of stars, quasars and neutron stars. The beginning of a glorious death. In the universe, an ending is often the beginning of something extraordinary. Every story in this chapter opens with a magnificent farewell, a supernova. The most massive stars, giants many times heavier than our sun, burn brightly but live briefly. They consume their fuel with urgency, fusing hydrogen into helium, then forging heavier elements such as carbon and silicon until they reach iron, the final limit of nuclear fusion. At that point, the star can no longer support its own weight. The iron core collapses in a fraction of a second. Gravity overwhelms all atomic structure, forcing matter into a state beyond ordinary language. From this violent collapse, the universe gives birth to its children of darkness and light. If the remaining core is moderate in mass, it becomes a neutron star. If it is too heavy, it collapses completely into a black hole, the hidden heart from which brilliant quasars are born. Neutron stars, matter at the edge of endurance. Neutron stars stand as monuments to the resilience of matter under unimaginable pressure. When the parent star explodes, its core is compressed so fiercely that electrons and protons merge, forming neutrons. What remains is a sphere only 10 to 12 kilometers in radius, no larger than a small city, yet holding nearly 1.5 times the mass of the Sun. Their density defies intuition. A single teaspoon of neutron star material would weigh as much as a mountain range, or every automobile on Earth combined. Gravity at the surface is so extreme that even a soft marshmallow would strike the ground with the energy of countless nuclear explosions. Many neutron stars spin at astonishing speeds, rotating hundreds of times per second, sending rhythmic pulses of radiation into space like the steady beat of a cosmic heart. We know these as pulsars, quasars, the great engines of galaxies. On a far grander scale, we encounter quasars, entities that are not merely the remains of a star, but the radiant hearts of ancient galaxies. At their center lie supermassive black holes, millions or even billions of times heavier than our Sun, engaged in an endless and powerful consumption of matter. The birth of a quasar is often written in chaos. When galaxies collide, vast clouds of gas and dust are driven inward, toward the waiting gravity of the central black hole. This material does not fall straight in, but spirals around it, forming a luminous accretion disk. Friction and gravitational pressure heat this disk to millions of degrees, transforming it into the brightest beacon in the observable universe. A quasar may be no larger than our solar system, yet it can shine thousands of times brighter than the entire Milky Way, home to hundreds of billions of stars. In that contrast lies one of the universe's quiet lessons. From the smallest regions, the greatest light can emerge. The relationship and the quiet distinction between two monsters. Although both quasars and neutron stars are born from the death of massive stars, they belong to very different realms of existence. To truly understand them, we must learn to separate their stories with care. Physical nature. Neutron stars are made of real matter, an extraordinarily dense, compact sphere of neutrons, tangible at least in theory. Quasars, by contrast, are not stars in any traditional sense. What we see is not a solid body, but light itself, energy released by a disk of matter spiraling just outside the event horizon of a black hole. Scale and mass. A neutron star weighs between about 1.4 and 2.17 times the mass of our Sun. Quasars, however, are powered by black holes whose masses range from 1 million to tens of billions of solar masses. In size, the difference is just as striking. A neutron star is no larger than a city, while a quasar's luminous region can span the scale of an entire solar system. Source of energy. Neutron stars shine through residual heat left behind by their violent birth, or through energy drawn from their rapid rotation and immensely strong magnetic fields. Quasars, on the other hand, are engines of consumption. They blaze only when matter falls inward to be devoured. When that supply is exhausted, the light fades, leaving behind a silent black hole. Distance and age. Neutron stars are our cosmic neighbors, scattered throughout the Milky Way. Quasars belong to a much earlier chapter of the universe. Most of them shone more than 10 billion years ago, their light traveling across unimaginable distances before finally reaching the human eye. How astronomers tell them apart. To avoid confusing these two star-like presences, astronomers rely on a set of careful observations, quiet keys that unlock their true identities. Redshift. This is the most decisive clue. Light from quasars is stretched dramatically toward the red end of the spectrum, a clear sign that it has crossed vast extragalactic distances as space itself expanded. Neutron stars, being much closer, show little redshift. When it appears, it is usually caused by the intense gravity at their surfaces, not by cosmic expansion. Periodicity. Neutron stars, especially pulsars, emit radio signals with astonishing regularity, as precise as the finest pendulum clock ever built. Quasars also emit radio waves, but their brightness fluctuates unpredictably, rising and falling with the irregular rhythm of matter being consumed by the black hole. Absolute brilliance. If a single point of light outshines hundreds of galaxies combined, there is no doubt. It is a quasar. Neutron stars, though fiercely hot and luminous, never reach such overwhelming levels of energy. The night is growing late now. The blazing torrents of quasar light and the steady heartbeat of distant pulsars begin to soften and fade within your thoughts. You have witnessed quasars, born from glorious death, burning like ancient gods in the darkness of the early universe. You have also encountered neutron stars, dense embers of collapsed suns, quietly keeping time in the void. Let your breathing become slow and gentle. You are here, safe within the calm embrace of a tranquil solar system, where those distant monsters are no more than pages of light, guiding you toward rest. Above you, the stars remain watchful, silent, and kind. Imagine a neutron star as a small yet perfectly faithful pendulum clock in a quiet room, and a quasar as a vast lighthouse standing far out at sea, one measuring each silent moment, the other opening a path through the mist of space and time. Let your breathing slow, becoming steady and gentle. Picture yourself lying on the deck of a quiet ship, drifting unhurriedly across the velvety black ocean of space. There are no city lights here, no schedules, no lingering concerns of daily life. After witnessing the violent beauty of birth from death, I now invite you to step into one of the strangest states matter can assume. This is a realm shaped by stillness and unimaginable pressure, where we listen not with our ears, but with our patience, to the invisible melodies the universe sends into the void. Welcome to the power of compression and radio music, when matter is cornered. The universe is, by nature, vast and mostly empty. Yet in a few extraordinary places, gravity presses matter into its most extreme trials. Let us begin with something familiar: a teaspoon. On Earth, it holds a pinch of sugar or salt. Nothing remarkable. But a single teaspoon of matter taken from a neutron star would weigh between 1 and 6 billion tons. That is the weight of all the cars, trucks, and buses on our planet, crushed into a space you could hold in your hand, or the mass of the entire Everest mountain range condensed into a single spoonful. This overwhelming pressure is born from the death of a massive star, one dozens of times heavier than our sun. When such a star ends its life in a supernova, its outer layers are blown into space, while the core collapses inward with brutal force. Gravity becomes so intense that atoms lose their familiar structure. Electrons and protons are pressed together until they merge, dissolving into neutrons. What remains is a sphere no larger than a small city, about 12 kilometers in radius, yet holding the mass of a colossal star. These conditions stretch far beyond ordinary imagination. If a marshmallow were dropped onto the surface of a neutron star, the impact would release energy equal to thousands of atomic bombs, simply because gravity there is billions of times stronger than on Earth. And yet, despite this violence, the surface is astonishingly smooth. Any mountain rising more than a few millimeters would be crushed flat almost instantly. This is matter pushed to the very edge of existence, balanced delicately between collapse and endurance. Quasar, the light engine born from compression and emptiness. If a neutron star is the glowing ember left behind by a single star, then a quasar is a vast engine of light, ignited at the heart of an entire galaxy. Here, compression does not act upon a solid surface, but within the invisible grip of a supermassive black hole engaged in a relentless feast. Imagine a region no larger than our solar system, yet shining thousands of times brighter than the Milky Way itself, a galaxy containing hundreds of billions of stars. To sustain such radiance, a quasar consumes matter at an astonishing pace, roughly 2 Earths every second, or the mass of hundreds of suns each year. As gas and dust are drawn inward, they do not fall straight into the black hole. Instead, they spiral, forming a glowing accretion disk. In this narrow, crowded space, matter races at near light speed. Friction and gravity heat it to millions of degrees, transforming mass into pure brilliance. The efficiency of this process reaches up to 32%, far surpassing the modest 0.7% achieved by nuclear fusion inside ordinary stars. A quasar stands as quiet testimony to a profound truth. When matter is compressed deeply enough, when gravity becomes inescapable, light itself is born in its most magnificent form. Radio melodies in the eternal night. The most remarkable bond between these two cosmic entities lies in how humanity first came to know them, through faint, unfamiliar radio melodies drifting out of the eternal night. In the 1950s and 1960s, when human beings first learned how to listen to the universe through radio waves, scientists detected signals that did not belong to any known star or galaxy. They were sounds without a visible source, quiet yet insistent, as if the cosmos itself were trying to speak. For neutron stars, some rotate at astonishing speeds, up to 716 revolutions per second, far faster than anything built by human hands. As they spin, they release narrow beams of radiation from their magnetic poles, like two immense lighthouse beams sweeping silently through space. Each time one of these beams crosses Earth, we receive a brief, perfectly timed radio pulse. When astronomers first detected these rhythms, their precision was so uncanny that the signals were temporarily labeled LGM1, short for Little Green Men, a reflection of just how puzzling they seemed. Yet the truth was far more profound. This was the steady heartbeat of a dead star, transformed into the most accurate natural clock the universe has ever produced. Quasars, by contrast, revealed themselves in a far more unruly voice. At first, they appeared as faint, star-like points of light, quasi-stellar in appearance. Yet they released radio energy so intense that it defied all known expectations. Unlike the disciplined rhythm of a pulsar, a quasar's radio emissions are violent and unpredictable. Their jets stretch for millions of light years, hurling charged particles at nearly the speed of light, forming vast radio structures, great cosmic ears that light up the deep intergalactic sky, the meeting point of two extremes. Despite their immense differences in scale, neutron stars and quasars tell a single, shared story, one of extreme compression and of light born from chaos. Both were once nothing more than mysterious radio ghosts, long before their true nature was understood. Neutron stars mark time with unwavering precision, their pulses echoing like the ticking of a flawless clock in the darkness. Quasars, meanwhile, serve as beacons reaching back nearly 13 billion years, allowing us to glimpse the universe in its youth. Together, they act as landmarks, lighthouses set within the vast map of emptiness, reminding us that space is not silent or static, but alive with the quiet music of energy. Now, as the images of compressed stellar cores and distant radio bursts slowly fade from your thoughts, allow your breathing to become light once more. You are here, safe within the calm spiral of the Milky Way. These distant monsters lie billions of light years away, far enough to leave your sleep undisturbed, yet luminous enough to kindle humanity's enduring curiosity. The universe continues its patient rhythm. Neutron stars still murmur like pendulum clocks in an empty room. Quasars still cast their distant light across the dark ocean of space. Together, they stand watch in absolute stillness. Imagine neutron stars as small, perfectly balanced clocks resting quietly on a table, giving meaning to every passing second. And imagine quasars as towering lighthouses on a far horizon, illuminating the deepest night, until, at last, both dissolve into the gentle silence of dawn. Relax your shoulders. Take a slow, deep breath, letting your chest expand. Then exhale gently, feeling the weight of the long day dissolve into the quiet. You are no longer in a narrow room, but drifting on a vessel of the mind, carried by the soft current of cosmic time. We have already passed through the turbulent chapters of creation and the era of hungry monsters. Tonight, we arrive at calm. Welcome to the sculptors and the serene silence. This is the story of two profound opposites, quasars and neutron stars, and how, through their unseen labor, they shape the universe, and why their present quiet is the sweetest lullaby for human life. The symphony of opposites, galactic engines and cosmic clocks. In the endless darkness, the universe forged two entities capable of compressing matter to unimaginable extremes, yet granted them entirely different ways of existing. Quasars are extravagant giants. They are not solitary stars, but the blazing hearts of ancient galaxies. At the center of each quasar lies a supermassive black hole, weighing millions, sometimes billions, of times more than our sun. A quasar functions as a vast engine of consumption. As gas and dust fall toward the black hole, they are not swallowed immediately. Instead, they spiral into a luminous accretion disk, releasing energy so immense that it can outshine the combined light of hundreds of billions of stars. Quasars are expressions of outward force, announcing their presence across the immense reaches of space. Neutron stars, by contrast, are quiet and enduring recluses. If a quasar is a cosmic fire capable of engulfing a solar system, then a neutron star is a compact sphere only 10 to 12 kilometers in radius, no larger than a small city. Yet within that modest size lies astonishing density. Born from the death of a massive star, neutron stars compress matter until protons and electrons merge into neutrons. Many rotate hundreds of times each second, emitting steady pulses of radiation like a measured heartbeat. These pulsars function as the most precise pendulum clocks the universe has ever known. Here lies their harmony. Quasars illuminate the cosmos through intense consumption, while neutron stars preserve order through quiet concentration, ensuring that time itself keeps moving forward. The sculptors. When destruction becomes the beginning of creation. It is natural to ask why such fierce and destructive entities are called sculptors. The answer is simple and profound. Without their violence, our own solar system would never have come to be. Quasars, the gardeners of galaxies. In the early universe, young galaxies burned with uncontrolled star formation. Left unchecked, they would have exhausted their gas and faded too quickly. Quasars intervened like gardeners wielding immense pruning shears. Their radiation and powerful winds, often described as quasar tsunamis, blew away excess gas, heating the interstellar medium and preventing stars from forming too rapidly. This deliberate restraint helped galaxies regulate their growth, preserving fuel so that stable stars, like our sun, could be born and shine for billions of years. Through destruction, quasars created balance. Neutron stars, the alchemists of life. While quasars shape the grand architecture of galaxies, neutron stars work on a more intimate scale. When two neutron stars spiral together and collide in a kilonova explosion, they create conditions so extreme that heavy elements are forged. Modern science tells us that much of the gold, platinum, and uranium in the universe was born in these violent unions. The gold in a ring, the calcium in your bones, the iron in your blood. Each is a relic of ancient neutron stars that lived and died billions of years ago. These silent alchemists scattered the raw materials from which habitable worlds and life itself could one day emerge. The settling silence, a gift of time and distance. Now that your breath feels as light as morning dew, pause for a moment and consider why we are safe. We are living in what astronomers gently call the settling silence. The brightest quasars belong mostly to a very distant past, nearly 10 billion years ago. As the universe has continued to expand, distance itself has become our quiet shield. Even the nearest known quasar lies some 600 million light-years from Earth. From such a vast separation, the once deadly torrents of radiation arrive here as nothing more than faint whispers of light, just enough for our most sensitive instruments to study, yet far too weak to disturb the delicate balance of Earth's living world. Our own Milky Way holds a supermassive black hole at its center, Sagittarius, a star. But unlike the ravenous quasars of the early universe, Sagittarius A star now sleeps. It no longer roars. It no longer floods space with violent outbursts of energy. Its calm is a rare and precious pause in the cosmic symphony, one that grants us quiet skies and nights gentle enough for dreams. Lullaby of the stars, quasars and neutron stars have fulfilled their great tasks. One carved order from chaos, shaping galaxies into stable homes. The other refined matter itself, forging the elements from which life would one day arise. They are our cosmic ancestors, creators who have stepped back into shadow so that conscious life might emerge. Let the images of blinding light and the steady pulses of distant pulsars slowly fade from your thoughts. You are here, on a small blue world, wrapped in the protection of immense distance. The stars above are no longer threats, but quiet guides, lighthouses for human curiosity, reminding us that we belong to something vast and enduring. Feel the calm of the infinite void. The universe continues its slow, patient expansion, carrying those ancient beacons ever closer to the horizon of eternity. The stars keep watch as you sleep. You are safe. You are sheltered. And tonight, in your dreams, you may travel freely across light years, sensing the quiet beauty of a cosmos shaped by light and shadow. Imagine a neutron star as a tiny yet perfectly faithful pendulum clock resting on a table, giving meaning to every passing moment, and a quasar as a great lighthouse standing over a boundless ocean, illuminating the farthest reaches of night, until both, at last, dissolve into the gentle silence of dawn. Close your eyes and allow your breath to settle into its most natural rhythm. Imagine yourself resting on a boat of the mind, drifting gently across a velvety black ocean of space, where the faint light of distant stars is woven into an eternal tapestry of reality. Tonight, I would like to share with you a reflection on one of the universe's great paradoxes, a quiet epic played by two forces capable of compressing matter beyond the limits of ordinary understanding: quasars and neutron stars. Their opposition is more than a question of physics. It is a grand portrait of balance, between death and renewal, between profound stillness and radiant excess. It all begins with the most magnificent farewell nature has ever composed: the supernova. When colossal stars, weighing dozens of times more than our sun, exhaust their final reserves of fuel, they collapse in an instant. From this violent ending, the universe branches into two very different destinies. If the remaining core holds a moderate mass, it contracts into a neutron star. But if that mass exceeds all restraint, it tears through space-time itself, forming a black hole, the immense engine that powers every brilliant quasar. I often find myself wondering why the universe gives rise to such opposing extremes. On one side stands the neutron star, an object of absolute inward focus. It is a nearly perfect sphere, no larger than a small city, with a radius of about 12 kilometers, yet it contains nearly 1.5 times the mass of the Sun. Consider that density. A single teaspoon of neutron star matter would weigh between 1 and 6 billion tons, as though every vehicle on Earth were pressed into the bowl of a spoon held in your hand. Its surface is unimaginably smooth. Even its tallest mountains rise only millimeters before gravity, billions of times stronger than Earth's, crushes them flat. A neutron star is a quiet ember, glowing faintly, spinning at astonishing speed, and sending out a steady radio rhythm, like the most precise pendulum clock nature has ever made. In contrast, a quasar is openly extravagant. It is not a single star, but the blazing heart of an ancient galaxy. At its center lies a supermassive black hole, indulging an endless appetite for matter. Where neutron stars shine with stored heat, quasars shine through consumption. Gas and dust spiral inward, forming a furious accretion disk where friction and gravity raise temperatures to millions of degrees. Though this region is small compared to the galaxy itself, it can outshine the combined light of hundreds of billions of stars, making it visible across billions of light years. Together, these opposites reveal a clear image of how the universe works. Neutron stars are like silent metallurgists. When two of them collide in a kilonova, they create conditions so extreme that heavy elements, gold, platinum, uranium, are forged. The necklace you wear, the iron in your blood, the calcium in your bones are all fragments born in these compact furnaces billions of years ago. Quasars, meanwhile, serve as cosmic sculptors. In the universe's early age, they illuminated the dense hydrogen fog, driving the process of reionization that made space transparent as we know it today. Their jets and powerful outflows swept away excess gas, preventing runaway star formation and allowing galaxies to mature steadily over billions of years. If neutron stars supply the raw materials for life, quasars prepare the environment in which that life can emerge and endure. There is a quiet gratitude in realizing that we live in what astronomers call a time of settling silence. The most ferocious quasars, those capable of consuming the mass of 2 Earths every second, belong largely to the distant past, some 10 billion years ago. Distance itself, the universe's greatest shield, has softened their influence. The nearest quasar lies about 600 million light-years away. By the time its light reaches your eyes, it is no more than a gentle whisper, a message from a violent era long concluded. Imagine for a moment if Earth were too close to a quasar like 3C273. At a distance of only 33 light-years, it would shine as brightly as the sun in our daytime sky. Yet that beauty would be catastrophic. Winds of charged particles, racing at tens of millions of kilometers per hour, would strip away our atmosphere, boil the oceans, and erase all life. Fortunately, the supermassive black hole at the center of our own galaxy, Sagittarius A star, is now in deep slumber, long past its most active phase. Its silence is a precious gift, granting humanity calm skies in which to look upward and dream. Our existence is the result of a remarkable arrangement. We owe neutron stars the atoms that form our bodies, and quasars the stable galactic home shaped by their fierce energy. One keeps time through perfect, steady pulses. The other opens the depths of space with torrents of light. Both once puzzled scientists with mysterious radio signals, long before their true nature was understood. The night grows late now, and images of compressed spheres and distant lighthouses begin to fade from your thoughts. You are here, safe within the gentle arms of the Milky Way, while the stars keep watch over your dreams. Beyond them, the universe continues its patient expansion, carrying distant quasars toward the far horizon of eternity. Let your breathing soften. Feel the calm of infinite space. You are not merely a passing observer, but part of this great story, stardust awakened to reflect on its own beginnings. Imagine a neutron star as a tiny yet perfectly faithful pendulum clock resting on a table, giving meaning to every moment, and a quasar as a vast lighthouse over a dark ocean, guiding our understanding toward the furthest reaches of night, until both dissolve into the quiet stillness of dawn. Sleep peacefully beneath this radiant Milky Way,